In most steam plants, the pressure produced by the boiler is higher than what many systems require. A pressure-reducing station safely lowers steam pressure to meet process demands while protecting downstream equipment. In this video, we will walk through the full layout of a pressure-reducing station, how the pressure-reducing valve works, the thermodynamic changes across the valve, and the critical safety features every operator must understand. Boilers are often operated at higher pressures for efficiency and distribution. However, many systems, such as heat exchangers, HVAC systems, sterilizers, and process equipment, require lower pressure steam. If high-pressure steam were supplied directly, it could cause equipment damage, poor process control, and safety hazards. The pressure-reducing station ensures stable, controlled, and safe steam delivery. A properly designed pressure-reducing station includes several components arranged in sequence. An inlet isolation valve allows the station to be isolated from the main steam header. A strainer protects the pressure-reducing valve by removing dirt and scale. The pressure-reducing valve is the core component that reduces and regulates downstream pressure. A downstream pressure gauge allows operators to verify reduced pressure. A safety relief valve protects downstream equipment from overpressure. An outlet isolation valve allows isolation of the downstream system. A bypass line provides manual control in case the pressure-reducing valve fails or is taken out of service. The pressure-reducing valve operates by modulating flow based on downstream pressure. Steam enters the valve at high pressure and flows through a restrictive orifice controlled by a valve plug. A sensing line transmits downstream pressure to a diaphragm or pilot system. When downstream pressure rises above the set point, the valve begins to close. When downstream pressure drops below the set point, the valve opens. This continuous adjustment maintains a constant downstream pressure, regardless of fluctuations upstream. When steam passes through a pressure-reducing valve, the process is known as throttling. This is a constant enthalpy process. As steam flows through the valve, pressure drops significantly. Temperature may decrease slightly, but often remains close to saturation depending on conditions. Enthalpy remains essentially constant during throttling. Entropy increases due to irreversibility and energy dissipation. Specific volume increases because the steam expands as pressure drops. This expansion allows high-pressure steam to be converted into usable lower-pressure steam without adding or removing heat. The bypass line is a critical backup feature. If the pressure-reducing valve fails or requires maintenance, operators can manually control steam flow using the bypass valve. However, bypass operation requires extreme caution as there is no automatic regulation. Improper use can easily overpressure downstream equipment. The safety valve is the last line of defense for the pressure-reducing station. It must be sized to handle the maximum flow through the pressure-reducing valve if it fails fully open, plus any additional flow through the bypass line. If the pressure-reducing valve fails open, full upstream pressure can reach the downstream system. The safety valve must be capable of relieving all incoming steam flow to prevent catastrophic overpressure. This is not optional. It is a critical safety requirement. Isolation valves are installed to allow safe maintenance and operation. These include the inlet isolation valve, outlet isolation valve, bypass isolation valve, and drain valves for condensate removal. Proper valve arrangement allows the pressure-reducing station to be serviced without shutting down the entire plant. A pressure-reducing station is more than just a valve. It is a complete system designed for control, protection, and reliability. From regulating pressure to protecting downstream equipment with safety valves and bypass systems, every component plays a critical role. Understanding how these systems operate and the thermodynamics behind them is essential knowledge for every stationary engineer. This has been Boiler Logic's breakdown of steam pressure reducing stations. Learn, connect, advance.